Hey YouTube, welcome back. Today we have this problem. It's called count negative numbers in a sorted matrix. It's a problem being asked by Amazon, Uber, and Microsoft, so it's a pretty famous one. The problem say given a MN matrix grid, which is sorted in non-increasing order. It is sorted, and this is quite important. Both row wise and column wise. Okay. Return the number of negative numbers in the grid. So we have this one. So the negative numbers are 8 because I have 4, 2, and 1 and 1. So it's 8. So how can we solve this one? Let me just take my pen. Okay. Let's go to the sketch because I will use this sketch a lot. Let's delete that. Okay. Let's take an example. So let's just take it one by one. Let's assume that we have each row. Maybe I have like a row that has like 0 and 1 and -1 and -2, and yeah, let's assume that we have this one. How can actually we can count the negative numbers? There is two ways that come to my mind. The one is to create brute force. Basically, you can loop and just to try to check each one, and this will be O of n. And because it's a grid, it will be n. It will be O of n m because the column and rows. Also, we can do something better, which is we can use a binary search, and this will be O of log n. Okay. So basically we can just take the left side and the right side, and after that we are in the right side. We can just take it side by side. Because it's sorted, we can use the binary search if we want. Basically what we can do here is just that we can just maybe the time complexity, I guess, no, the time complexity, it will be n log n, and because it's a matrix, it will be O of m plus n. Yeah, exactly. So what are we going to do? Let's just try to check these things out. We have this. So basically we could the algorithm that we do, maybe we could create a count that just we could count the total number of the negative numbers and we return it. We maybe have n, a variable called n, and it to store the number of elements in each row. Maybe you have another one called the current row negative index or something like that. This one to store the current row's first negative elements index. And yeah, that's, I guess that's it. Let's just start in the, where is the, oh, not this one. Yeah, this is it. Okay, so let's see. First of all, let's just create our variable. So let count, and count will equal 0, and I will return this count. Okay, and after that I will say let n equals grid of 0 dot length, and let the current row negative index, and this will equals n minus 1. And you will know why we're using this. It will be pretty useful, but just be patient with it. And I would say sorry, no, go back. and I will say maybe I will do a loop or something. Let's just like for let row of grid, and I will say the thing that I think that we decrease the current negative index so that it is points to the current row's last positive index or last positive element. So I will say while the oh, while the current row index is bigger than or equals 0 and the row of current index is less than 0, that means we didn't find our first positive integrate, so it will be current index minus minus. And I will say the thing that we can count, like count, will be plus equal n minus again here on here current index plus 1. If you don't understand this one, let's just take an example, because this one is pretty easy to understand this example. So let's say that we have this grid, this array. It has 1, 2, no, sorry, it has 4, 3, 2, and maybe -1 and -2. So we started here, and we don't know how many negative values are there. So we start at the end. I would say that let's say that the current will equals 1, 2, 3, 4, 5. It will equals 4. So you start to say, is this value is negative? Yeah, so take 1 from this one. So it will be 3. If this value is negative, yes, take 1 from this one. So the value is 2. So yeah, we will be here at 2 basically. So if we want to know how much values are there, so it's 5 minus 2 plus 1, it will equals 2. So basically this is the way that we could get our values in this equation. Will give us our values, and basically that's it. It's I guess, yeah, that's it. Yeah, and but I guess this is not a binary search. This is a linear traverse. This is not a binary search. Sorry for saying it's a binary search. This one is a linear traverse. We could do a binary search. Let's do a binary search one. So basically this is a solution. Let's just check it first. Yeah, it's working. Okay, let's I will commit this solution. Let's create a copy, and I'll put this solution here so you can just see, because actually I will copy my solution anyway. Let's go through the binary search solution. So in the binary search solution, we just create let count. I guess we only need to count and I guess we only maybe need to do these two. Oh, no, not shit. And I will. Okay. Can I put this one downstairs? I guess because it will be better to see. Okay. This one and this one the time complexity, sorry, it will be O of OM log n, O of M log n, the O of n plus n. Okay, the linear search. Okay, I did this problem, sorry. This O of n plus m, this is the time complexity. The time complexity of the above, it will be O of m log n. Anyway, let's just continue in solving this one. So I will say let's say for, I will say const row of grid const row of grid. I will say, first of all, when you do binary search, you have mid, you have left, you have right. It's 2 pointers you use with it. So const mid will equals first of all, I guess we need to declare the left and right. Let me just make the code looks a little bit cleaner to, or a little bit readable. Okay. So let's just let left and left all the time equals 0. Let right, it will equals I guess n minus 1, because we will wanna target the last element. And I guess I will make a while loop, and it's as always while left is less than or equals right. And I will say const mid equals math dot flow right plus left, plus left divided by 2. Okay, and I will say if, maybe I will say right here, so I have mid and I have left. I will say if row dot mid is row of mid is less than 0, I will increase right. I will make right equals mid, and after that I will start to declare a new mid and new left. And okay, let's just do this code, and I'll just try to describe it. It's less than 0. I will say right will equals mid minus 1, else left will equals mid, left will equals mid plus 1. And after ending the while loop, I guess that count plus equal n minus left. Okay, I guess n minus left, you have just seen something here, which is the current row index. And I will describe the linear traverse, but just let me just do this one, and I will return count. Sorry, actually I was planning to do both. I was planning to start with the binary search and linear, but I just forgot, and I just first described the binary search, and directly I went to solve the linear. So sorry if this will make you a little bit confused. Sorry for that. So what I'm going to say, first of all, let's just look at this one. So we have count and we have ingrid. We have our left, we have our right. Let's just say that, let's take this an example. Okay. So our left points to 4, our right points to -1. So I say that if row dot mid and row dot mid, it equals this, equals, yeah, it will equals 2 or 3, I don't know. No, it will equals 3, it equals 3. So if row dot mid less than 0, I guess no. So row dot mid is bigger than 0. So left will equals, that means all, because it's a sorted array, all of the left side equals to bigger than 0. Okay, so we make mid we increase the left side, and we just make the left side 2, and we'll just try to continue, and we will continue until the moment that we will find that left will equals, like, this equation will give me 1 by the end, because n is 4, and left it will equals 2, and after that we increase it again, because mid will be only again 2, so it will be 4. So 4 minus 5, it will be 1. We return count. So that's it. In the linear, actually, let's just talk in the linear, actually, in in the linear approach, that in this problem, basically it's given that the numbers are also sorted in column wise, not also in order wise. So this implies that if the ith row has the first negative element at index x, then the first negative for the I plus 1 row can never be indices greater than x, because it's also sorted in column wise. You know what I mean? So because of that, this linear approach work, because we take that means that it's also sorted by column. So yeah, so that's it for this video. We have 2 solutions. I hope you like them. This one, it will be time complexity of O of m log n, and yeah, it's O of m log n, and the other one O of m plus n. So yeah, that's it for this video. I hope it was quite good. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.